Hey guys, today we're going to talk about dilations. So, what's a dilation? A dilation is a transformation where a figure has its size changed. It can get either bigger or smaller. If the dilation is greater than 1, it's an enlargement. If it's between 0 and 1, it's a contraction, so it shrinks. It also has something called a center of dilation. That's the point from which the expansion or contraction takes place. Most of the ones we're going to do is from the origin, 0, 0. So, tell whether this figure is a dilation, if the blue figure is a dilation of the red figure. So one way to do that, notice they're exactly the same shape, they're just a different size. One way to do that is to take corresponding points like these two and connect them with a line like this. And then we can take some more corresponding points that go together. You need to do at least 2 like this. And it's probably best to do 3, so we can take these 2 and do this. And notice they all meet right here. Okay, that's called the center of dilation. And you can see as this spreads out like this, it makes an equivalent shape that's just larger the further away you get from the center of dilation. It gets smaller the closer you get to the center of dilation. So if this occurs where you get a center like this and you connect the key points and they all meet right here, that is a dilation. Okay, so tell whether the blue figure is a dilation of the red figure here. So we do the same thing. We can take this, connect those 2 points, we can connect these 2 points, and we can connect these 2 points. And look what happens here. In this one, we've got parallel lines. These are never going to meet, no matter how far out here I draw them. Okay? So this is not a dilation. This would just be a slide. This would be a translation that just slides it from here to here. Okay. The image and the pre-image of a dilation are similar figures, and the ratio between them is called the scale factor. That's important to know what a scale factor is. So to dilate a figure with respect to the origin, you simply multiply the coordinates of the pre-image by a constant. That constant is the scale factor. So for example, if we take triangle ABC, that's this little red one right here, and we're going to expand it with a scale factor of 3. So we're going to take xy and we're going to change it to 3x, 3y. Now if I do that, that's going to give me a size change or a dilation with a scale factor of whatever this number is right here. These should be the same for both the x and the y coordinate. Okay, and the center of the dilation is going to be the origin. Okay, so you can kind of see here, this is pretty obvious. There's a line that goes through those 2, there's a line that goes through those 2, and if I follow, up 1 over 1, up 1 over 1, up 1 over 1, boom, it's going to go through the B and B prime there. So if I do my mapping, 0, 2, that's point A, is going to go to 0, 6, and that's going to equal A prime. And then 2, 2 is going to go to 3 times 2, 3 times 2, so that's going to be 6, 6, that's going to be B prime. And 0, 2, whoops, this was 2, 0 right here. 0, 2 is A. I got those backwards on the picture, don't I? Oh, I'm sorry, I got a typo right here. This should be 2, 0. Is going to go to 6, 0. That's going to be C prime. Okay, so you can look here, there's 6, 0, there's 6, 6, and there's 0, 6. And I did my dilation there. So a dilation with a scale factor greater than 1 is called an expansion. So this one, it was 3, it expanded. If I have it between 0 and 1, it's a contraction. So if this was my original one, if this was my pre-image here, and I did a scale factor of 1/3, okay, so 6, 6 would then become 2, 2. So this thing would shrink towards the origin then. Now would be a contraction. You never have a dilation that has a scale factor that is negative. Okay, so draw the image of a dilation with a scale factor of 4 for triangle XYZ with coordinates of x is negative 2, 2. Let's make sure I got these right this time. Y is at 2, 2. And z is at 0, negative 1. Okay, so let's see here. If I take a, or x, that's going to be negative 2, 2. And I use a scale factor of 4, that's going to go to negative 8, 8. That's going to be x prime. So let's go ahead and graph negative 8, 8. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 2, 4, 6, 8, right there. So there's x prime. Y is going to start out at 2, 2. But when I do my scale factor of 4, that's going to become 8, 8. That's going to be y prime. So that's going to go right there. And then z, which is 0, negative 1, is going to go to 0, negative 4. That's going to be z prime. So that's going to go to right here. Okay, so then I could connect these like this. And I got, notice it expanded away from the origin, okay? If I took a dotted line and I went from, that's not what I meant to do. I went from here you can see that it goes through x and x prime and the origin, and I could do the same thing from y to y prime in the origin and from z to z prime in the origin. Oops, this is supposed to be z prime here. Okay, so there we go. The triangle became 4 times bigger. Notice this too. This side is parallel to this side. YZ is parallel to Y prime Z prime, and XY is parallel to X prime Y prime. And that happened over here too. AC and A prime C prime are parallel, AB and A prime B prime are parallel, and BC and B prime C prime are parallel as well. Okay, draw the image of the rectangle ABCD with a scale factor of 5. Oh, I'm sorry, that's 0.5 I was going to say. That's going to go way off the graph. 0.5. Okay, so I got negative 6, negative 8 is point A down here. That's going to go to negative 3, negative 4, and that's going to be A prime. So let's graph that. Negative 3, negative 4. Negative 6, positive 6 is going to become negative 3, positive 3. That's going to be B prime. Negative 3, positive 3. C prime is going to go to 2, 3. That's C prime. 2, 3 is going to be right here. And D prime is going to be at 2, negative 4. 2, negative 4. And so this time you can see that this thing is a contraction. Okay, it shrunk towards the origin. So pretty simple to do. I would use graph paper for this, so you got nice and a straight edge, so that you've got a nice drawing. Okay, how do you use more than one transformation? So on this one, the vertices of a trapezoid are at A is -2, -1, B is at -1, 1, C is at 0, 1, and D is at 0, -1. So we got those all graphed here, this nice little red one right here. Okay. Now we're going to dilate the trapezoid with respect to the origin using a scale factor of 2. Okay. So this thing is going to get twice as big. Okay, so this is going to go to -4, -2. This should go to -2, +2. This is going to stay 0, 2, and this is going to be 0, -2. All right, so let's go ahead and graph those. -4, -2 would be right here. And -2, -2 would be right here. Oh, I'm sorry, that's -2, +2. -2, +2. 0, 2. Be right there. And 0, -2 would be right here. All right, so we're going to go ahead and we'll graph this like that. Okay. Now we're going to take these and we're going to translate it 6 units right and 2 units up. So what is that going to do? Well, this one took XY. Should have probably written this out. This one took XY and transformed it to, let's see, it was a scale factor of 2, so it took it to 2x, 2y, and then that is going to go to, it's going to be 6 units right, so that's going to be 2x plus 6, and 2 units up, so that's going to be 2x plus 2. Okay, so I'm going to take each one of these. The 2x has already been done. I just got to add 6, so this is going to be 2, and this is going to be 0. Then this is going to be 4, and this is going to be 4, and this is going to be 6, and this should be 4, and this one is going to be 6, and this one should be 0. Okay, so let's check it out here. 2, 0 would be right here, and 4, 4 would be right here. 6, 4 would be right here, and 6, 0 would be right there. So we'll go ahead and connect these with nice straight lines. And there you go. So let's see, this would be A double prime, this would be B double prime, C double prime, and D double prime right here. So we enlarged this thing to twice as big, and then we moved each point up to and to the right, 1, 2, 3, 4, 5, 6. Now, if you used this this mapping right here, that would take you, if you actually use the 2x, it would take you directly from here all the way over to here. You'd kind of skip this step in between. Okay, so here you go. Here's a few problems that we will do in class, and hopefully this was a good video for you, and I will see you next time.